This is question 9. A Newtonian fluid having a specific gravity of 0.9 and a kinematic viscosity nu of 4 times 10 to the power of negative 4 meters square per second form a boundary layer near a solid wall of cubic velocity profile. The boundary layer thickness delta is 6 mm and the maximum velocity is 10 meter per second. Determine the shear stress tau in the boundary layer at y equal to 0 mm and y equal to 3 mm, and then we need to calculate the drag force. So this is the situation that occur when a free stream velocity flow on a solid surface. So it doesn't have a moving plate and fixed plate. So we have a plate here. So we have a plate here, and then this molecule will have u equal to 0 because there are no slip condition. So and then the velocity become larger and larger, and at one certain point the velocity will reach the maximum condition. So in this case it is equal to 10 meter per second. So and then this height from here to here is determined as boundary layer thickness. So the symbol is delta. So and then the curve here can be represent of the equation of this one, u over capital U 3 over 2 y per delta minus 1 over u y per delta cube. So and then the wall area, which is the A here, is equal to 5 meters square. So and then what we need to do is we just list down all the parameters. So we have the specific gravity, we have the kinematic viscosity, so and then we have the value of S here, so 0.06. So we have the U 10 meter per second. So this is the relation of kinematic viscosity, and this is the dynamic viscosity of 0.36 kilogram per meter per second. So the 0.006 meter here is actually the boundary layer thickness is 6 mm. So mean the distance of this one is 6 millimeter. So in SI unit, so it written as 0.006 meter. So and then I think in our previous tutorial I show you how to solve this problem. So we have the equation of u over u like this one, and then we could differentiate into du over dy, and then we could get it is equal to 3 over 2 u over delta minus 3 over 2 y square over delta 3 delta cube u. So and then for y equal to 0 millimeter here, so we substitute the value of y equal to 0. So means that the value of delta here is equal to 0 here, the value of y here. So and then we could get that it is equal of this one. So it is equal to 900 Newton per meter square. So this is the du dy. So and then we write the value of du dy when y is equal to 0. So we substitute the value of y. So we put the value of y here at this place. So the total value here is equal to 0. That's why the calculation is only based on 3 over 2 u over delta. So that's why we use this one. So and then we substitute all the value, we get 900 Newton per meter square. So and then we substitute the value of y equal to 3 mm. So please make sure that you write in SI unit, which is 0.003 meter, and then we get 675 Newton per meter square. And then we could calculate the drag force, which is F is equal to tau A. So we take the maximum value of shear stress here, so which is 900. So we times with the area. So according to the question here, so the area is 5 meters square. So we substitute the value, so we get the drag force is around 4,500 Newton.